We are going to discuss Cannizzaro reaction. Cannizzaro reaction is nothing but it is the redox reaction. It is redox reaction. It is shown by aldehyde. This reaction is shown by aldehyde, and essentially it is shown by aldehyde which do not contains alpha hydrogen. Alpha hydrogen means what? In aldol condensation we have seen if the carbon is present adjacent to carbonyl it is alpha, and the hydrogen it is present it is alpha hydrogen. But in this reaction we don't want alpha hydrogen. We don't want alpha hydrogen. No alpha hydrogen. So which are these aldehyde which do not contain alpha hydrogen? First of all, formaldehyde. This is formaldehyde. Then another example is benzaldehyde. These aldehydes do not contain alpha hydrogen. As they do not contain alpha hydrogen, they shows Cannizzaro reaction. In the Cannizzaro reaction, the another most important thing that you requires concentrated base. The conditions are opposite to aldol condensation reaction. First of all, you know that concentrated base will act as a nucleophile. Now what is going to happen if you will take aldehyde which do not contain alpha hydrogen, if you will take similar aldehyde, and if you carry out this reaction in the presence of concentrated NaOH or concentrated base, if you will carry out this reaction in the presence of concentrated base, then the product of the reaction, that one molecule will undergo oxidation. Aldehyde upon oxidation gives carboxylic acid, and aldehyde upon reduction gives alcohol. So this you will get a mixture of this thing. Here you are getting alcohol and here you are getting aldehyde. This carboxylic acid, it is oxidation product, and this is reduction process. So oxidation and reduction taking place simultaneously. That's why this reaction is known as redox reaction. This reaction is known as a redox reaction. The very interesting concept is that this reaction is a redox reaction. Now, this reaction is a redox reaction shown by aldehyde. And does not shown by ketone. It's a very important thing. Now, what are the conditions? Absence of alpha hydrogen, number 1. Number 2, only aldehyde. And number 3, reaction takes place in the presence of concentrated base. These 3 conditions are there. It is a must. Now, Cannizzaro reactions are of 2 different types: Self-Cannizzaro and Cross-Cannizzaro. What you will understand by self? If two reacting molecules are similar, like acetaldehyde, acetaldehyde, it is self-aldol, a self-Cannizzaro. And if you are having similar, this is also example of self-Cannizzaro. But if you are having two molecules are different, then that Cannizzaro is cross-Cannizzaro reaction. Now in this, there is no issue. One will undergo oxidation, one will go reduction. But in these, which will undergo oxidation and which will go reduction? For that purpose, you should understand it depends upon reactivity of aldehyde. Before going to the cross, first of all, we'll discuss the mechanism and formation of self-Cannizzaro reaction. First of all, see, I'll write down one reaction for you. I'll take first molecule. This is the first molecule, formaldehyde. As I have used concentrated base, that is OH minus. If concentrated base is there, OH minus is acting as a nucleophile. So it will attack on this. This will go to this. So you will get HC. I'll write down OH over here. Here it is H and this is O minus. This is your first molecule. It is hydroxy alkoxide ion. It is hydroxy alkoxide ion. It is hydroxy alkoxide ion. This is first molecule. That molecule is reacting with our second molecule of formaldehyde. In this formaldehyde molecule, what is going to happen? Please see this O minus will get revert and this H will get attack on this as a H minus and you will get product as HC double bond O OH plus HC OH O minus H and H. This will give H plus, so it will form HC double bond O O minus Na plus plus CH3OH. It is sodium salt of carboxylic acid. It is known as sodium acetate. And this is methanol. Now, this is the product of oxidation and this is the product of reduction. We are getting both the product. That's why this reaction is known as disproportionate reaction. Disproportionate reaction. Now, as reactivity of both the thing, it is same. As reactivity of both the thing, it is same. That's why we have got one acid and one alcohol. Okay. Same thing. This is the first reaction. Same thing if you will take benzaldehyde. Mechanism is one and the same. If you will take benzaldehyde molecule and when you will treat that benzaldehyde molecule with another benzaldehyde molecule, that is self-Cannizzaro. One molecule will undergo oxidation, one molecule will undergo reduction in the presence of 50% of NaOH. I'll write down here only the thing. This OH minus will attack on this actually, and this H is going to attack on this. The product will be, I'll write down directly the product, sodium benzoate. So it is oxidized product. In short, it is benzoic acid. And another you will get that will be a benzyl alcohol. So one will be oxidation, one will be redox. This is a very, very important reaction. Now there is no any issue because one molecule will undergo oxidation both out of that and one molecule will undergo reduction. But if you will go for cross, for example, you are having this formaldehyde and you are having benzaldehyde. The question comes, if this is the example of Cross-Cannizzaro. Now question comes that this OH minus, this will attack on first on which molecule, A or B? This is A and this is B. Attack of OH minus totally depends upon reactivity. The molecule which is more reactive or the carbonyl which is more deficient, the carbonyl carbon, which carbonyl is more, which carbonyl carbon is more electron deficient, that is more reactive, and OH minus will attack on it. Now all of you know that this molecule, this carbonyl is delta positive, this is delta negative. This is benzaldehyde molecule. This benzaldehyde molecule, there is a presence of a carbonyl group H. What is going to happen in benzaldehyde molecule? This benzene ring, there is an adjacent carbonyl over here. This is delta positive, this is delta negative. But what is going to happen? This benzene ring shows its plus R effect. And when benzene ring shows its plus R effect, so definitely such a type of thing is going to happen. So when such a type of thing is going to happen, now if it is going to happen, what is going to happen? Then you will get such a type of structure. And here the carbonyl deficiency will decrease. So out of that, this is aliphatic and this is aromatic aldehyde. Because of this, aliphatic aldehyde is more reactive than aromatic aldehyde. More reactive. So definitely what is going to happen? That OH minus will first of all attack on aliphatic aldehyde. So what will be the reaction? Please see. So this OH, as it is more reactive, that's why OH minus will first attack on that aliphatic. This will go to this and you will get H, this is OH and here it is O minus Then it will react with second molecule, that is benzaldehyde, double bond O, H, because it is less reactive. So this will come to this, and this negatively charged H will attack on this. The product will be HC double bond O, OH plus benzene ring. Then it is H, H and O minus. Exchange will take place. It will form HC double bond O, O minus, Na plus, and it will become benzene ring means CH2OH. So it is benzyl alcohol. So in short, out of that, this is A molecule, this is B molecule. The molecule which is more reactive, the aldehyde, which is more reactive, aldehyde, which is more reactive, it will be converted to acid, and the aldehyde which is less reactive, it will get converted into alcohol. So we can write down different examples. In short, very nice or simple examples we will discuss. So first example is that if I'll take benzaldehyde, and if with benzaldehyde, if I'll take another aromatic aldehyde, so with respect to that aromatic aldehyde, there is a NH2 group, number 1. So we have to carry out this reaction. 50% NaOH. So we have to write down the product of this. Out of this, all of you know that NH2 is electron donating, and aldehydic group is present as para position. So what is going to happen? This will go to this, this will go to this, this will go to this. Definitely delocalization. So out of these two aldehyde, this aldehyde is more reactive. As this aldehyde is more reactive, so that will get converted into acid. And the aldehyde which is less reactive, that aldehyde is getting converted into alcohol. So this is the very important concept. So first of all, you have to understand this. Another example also we can take, if you are having benzaldehyde, and if you are having another aromatic aldehyde, so this example is up to this, and another aromatic aldehyde, and there is a presence of NO2 group. Now this aldehyde is more, so this aldehyde is getting converted into acid, and this is getting converted into alcohol. So this is the very famous reaction known as Cannizzaro reaction. We have discussed Cannizzaro reaction. What is the condition for Cannizzaro reaction? It's shown by aldehyde. It's shown by one molecule undergo oxidation, one molecule will undergo reduction. So if it is self, there is no issue. But if it is cross, the aldehyde which is more reactive, that will get converted into carboxylic acid. The aldehyde which is less reactive, it is getting converted into alcohol. So if you have liked my lecture, please like it. Please press bell button and subscribe my channel. Thank you.